you go to test it at all, you write out like zero or something.
Yes. I do that all the time for my typos because it's funny.
All right.
Right, in purple today.
So we were talking about continuity of piecewise functions, right? So like, for example,
C.
if I gave you a function f of x equals 7 minus 3x squared if x is greater than -2, and -2 plus 3x if x is less than or equal to -2. Remember, the way that you test for continuity is you first just ensure that -2 is included in one of these intervals, right? Which it definitely is, since it's less than or equal to. What do you do next? Yeah, you just plug in -2 to the first piece, and you plug in -2 to the second piece, and you make sure you get the same answer, because that's making sure that the limit exists and that the limit is equal to the value of the function at that point. So you're really testing to see if 7 minus 3 times -2 squared is equal to -2 plus 3 times -2. That's what you're really testing for here. So this is 7 minus 12. You want to know, is that equal to -2 minus 6? Right?
Yeah.
Okay, I thought this one actually was continuous. Must have made a copying error. All right, so this would be -5 is definitely not equal to -8. So you'd say, nope, this is not continuous because the limit does not exist. Everybody okay with that process?
Yeah.
Any other questions on that? Okay, so today's stuff builds off that. It's just more continuity of continuous functions. Of piecewise functions. More continuity of piecewise functions. Let me just look at this again, make sure I didn't make a mistake. I don't know what I did wrong. I must have copied it wrong because I actually thought that this was a continuous example. So, all right. So more continuity of piecewise functions. So in this case, what they're going to do is they're going to give you a piecewise function that has like missing parts. And they're going to ask you to find the missing parts if you know the function is continuous. Like, for example, suppose we have something like f of x equals kx squared if x is greater than 2, and kx plus 4 if x is less than or equal to 2. So the directions would say, find k if f of x is continuous. So it's really the same idea, right? In order for f of x to be continuous, 3 things have to occur. First of all is f of, well, these are both polynomials, so you know each of the pieces are continuous on their own, right? So really the only questionable point is that x equals 2. So 2 has to be included in one of these intervals, which it is. And then the limit has to exist. Well, how do you get the limit? You take 2 and you plug it in here for x, not for k. And you take 2 and you plug it in here for x. And you make sure you get the same thing. Yeah, exactly. So that's all you're going to do here. If you know that f of x is continuous, that means that when you plug 2 in here, you get 4k. That has to equal what you get when you plug 2 in here, 2k plus 4. Does that make sense? That's the way to ensure that the limit exists, is if plugging 2 in here gives you the same thing as plugging 2 in here. So this would end up being 2k equals 4, so k has to be 2. That's the value of k that would ensure that the limit exists in this case. And the limit has to exist because they tell you it's continuous. Okay? Let's try another one. How about if it was something like f of x equals k squared minus 12k, or 12x rather, minus 12x, k squared minus 12x, if x is greater than or equal to 6, and kx if x is less than 6. Same question, f of x is continuous, find the value of k. So same process, I'm just going to make sure that 6 is here, which it is, and then I'm going to plug 6 in for x in the top piece, and plug 6 in for x in the bottom piece. Now, a common mistake people make is they accidentally plug 6 in for k. K is not the variable of the function. K is like the unknown constant that we're trying to find. Okay, so that's the difference. You're plugging this number in for x in all these examples. So this is going to be k squared minus 12 times 6 equals k times 6. Okay, so this is a little bit more complicated example because it ends up being a quadratic that you have to solve for k. K squared minus 72 equals 6k. How do I solve a quadratic like this?
You get them all on the same side.
Yeah, standard form. So k squared minus 6k minus 72. Yeah, and then hopefully it factors. Does this factor? Yeah, 12 times 6. So this would be k minus 12, k plus 6. So k equals 12, or it could be negative 6. Both of them would work. There's no reason why it can't be a negative number here, right? It's just a constant in the function. So either one of these would work. There's two possible answers. So remember on delta math, if there's two possible answers, you got to press that little plus button to give you two little spaces to fill. Okay. Let's try a different type of problem. What if I have something like this? F of x equals two pieces. Let's suppose the first piece is x squared plus 7x plus 10 over x squared plus 2x minus 15. So that, if x does not equal negative 5, and it's k, if x does equal negative 5. And the directions here would say, find the value of k that makes this function continuous at negative 5. So find value of k that makes f of x continuous at x equals negative 5. Well, in order for it to be continuous at x equals negative 5, f of negative 5 has to exist, which it is. It's k. The limit has to exist, which we have to evaluate that. And then the limit has to equal f of negative 5. So essentially, this just has to equal whatever the limit as x goes to negative 5 is of this function. Does that make sense? K has to equal the limit as x goes to negative 5 of f of x, which around negative 5, f of x is equal to this function right here. X squared plus 7x plus 10 divided by x squared plus 2x minus 15. Does this make sense that this is what it has to be? In order for the function to be continuous at negative 5, f of negative 5 has to exist, the limit has to exist, and the limit has to equal f of negative 5, which is what this is saying. So remember the process, you plug negative 5 in, it doesn't work, it gives you 0 over 0. What do you do second? Factor. This factors. This is going to be x plus 5, x plus 2 on the top, and x plus 5, x minus 3 on the bottom. So then those cancel. What do I do now? Yeah, just plug in -5. So I have -5 plus 2, -3, over -5 minus 3. So the answer is 3/8. That's what k has to be in order for this function to be continuous at -5. Does that make sense in theory and also like what I did? Okay, let's do one more like this. How about something like f of x equals x squared minus 10x plus 21 over x squared minus 6x minus 7. If x does not equal 7, k if x equals 7. So same exact type of problem. K has to equal the limit as x goes to 7 of x squared minus 10x plus 21 over x squared minus 6x minus 7. So again, you get 0 over 0. So when I factor this, the top's going to factor as x minus 7, x plus 3, or x minus 3 rather, minus 7, minus 3. Two numbers that multiply to give you negative or positive 21 and add to give you negative 10. And then on the bottom, you get x minus 7, x plus 1. So the x minus 7's cancel. Then you can just substitute in 7 and you get 4/8. So the answer is 4.5. Because that's the limit as x goes to 7. Okay, so if it's a problem like this, where k is defined to be the function at a particular point, and then there's a different function at every other point, then k is just the limit. But if it's a problem like these ones up here, you just substitute the number where the function changes into both pieces and set them equal and solve for k.
Okay.
Pretty easy?
Yep.
All right, so the homework's on Delta Math, and it's just called more continuity of piecewise functions. That's it. All right.
I left my jacket in the art room. Can I go to
Yeah, of course. I'll do that.
Yeah.